Hello and welcome to our discussion on solubility. So today we're going to talk about solubility of substances and solutions and what that means. So at the end of this, you will be able to understand how to read a solubility graph, and you'll be able to look at unsaturated, saturated, and supersaturated solutions and understand what that means, both definition-wise and based on their location in a graph. So for starters, solubility is used to describe how much solute is dissolved or can be dissolved in a solution, or to make a solution. Describe how much solute can be dissolved to make a solution. Definition-wise, it is the maximum amount of solute. We're talking solute, we're talking the maximum amount of solute that can be dissolved in 100 grams of water at a given temperature. Okay, so that's our solubility definition, is the maximum amount of solute that can be dissolved in 100 grams of solvent, typically water, at a given temperature. And then we're going to look at that here. So there are three types of solutions. We're looking at the amount that they can dissolve. The first one is called unsaturated. Unsaturated solution has, or is defined as a solution that has less than the maximum amount of solute dissolved in it. So has less than the maximum amount of solute. A saturated solution, for comparison, we think of saturated, we are talking about it contains the maximum amount of solute at a given temperature. And then, so if we have one that's less than the maximum amount and another one that is the maximum amount, supersaturated then is going to be, contains solute is dissolved at a higher temperature, and then the solution is allowed to cool, so there is more solute dissolved than normally possible. That's the kind of the key piece to that definition. And so if you heat a solution up, and we'll talk about this in a second, if you heat a liquid up, a solution up, in general, it can dissolve more solutes. And specifically for solid solutes, you can dissolve more solutes in warmer solvents. And so if you heat your solvent up and dissolve excess solutes in it and then let it cool, some of those, sometimes they will stay suspended and you'll end up with more than what you're supposed to. That is called a supersaturated solution. So on a graph, it looks like this. You notice on the bottom we're looking at temperature, and on the side we're looking at solute in grams, the amount of solute dissolved per 100 grams of water. And this is our solubility chart. This is what we're going to have to look at and be able to utilize. And this is temperature. Typically temperatures in Celsius, degrees Celsius, can be any temperature. You just need to know temperature's going up. So there's three regions to this graph. So if we're looking at this line, let's pretend that this line here goes or belongs to KNO3. So we're looking at potassium nitrate, and this is the solubility graph for potassium nitrate. If I have an amount of solute over here and a temperature here, and they meet at this point, if I have this much solute dissolved in my water, this much KNO3 dissolved in my water so I have this amount of KNO3 and I have this temperature, this is going to create an unsaturated solution because it is below the line. So this line, because it says it's saturated, this is what this means, is if my amount of solute and my temperature, if I connect those two dots and they end up right on this line, right on that line there, that is going to be a saturated solution. So anything that falls under this line is unsaturated. On the line is saturated. If I would end up with an amount up here, so for example, I heated it at least to this temperature, at least to here, and then I let it cool, and it cooled down to this temperature here, this solute can still be dissolved even though I'm only supposed to have this much. So this would be a supersaturated solution. And the way we can tell this is we can drop a crystal of solute into the solution and see what happens. So if it's unsaturated, for example, if I would drop some more KNO3 in this, it's going to simply raise up here and it's going to dissolve. So that solute's going to dissolve because I'm not saturated yet. If I'm already at the saturation point and I put more crystals in, The idea behind saturated is it can't hold anymore, so those crystals will float to the bottom and stay a solid. If I put it into a supersaturated solution, so it looks clear and I put a crystal in, but if it's supersaturated already, meaning it's got more than it's supposed to at that temperature, this is what happens. Oops, let me go back quick. Okay, so here you see on this first picture, this is a little crystal being placed into what looks like a beaker full of water. When that crystal lands, those particles, those dissolved particles, understand how they arrange and how they can come together and form a solid, and then everything happens here, and you have a whole bunch of them come out, and it essentially fills your beaker with solid substances. That is the supersaturated solution. That's a supersaturated solution, and that's what happens when you place a crystal into one of them. This is a solubility chart that has a couple different substances. So you look at different substances. Different substances have different solubilities. For example, you'll see C12H22O11, which is sucrose, I believe, up at the top. The solubility here, it can dissolve more of that than we can lithium chloride at the same temperature. And same with potassium chloride and sodium chloride. I can always dissolve more of this than I can these other guys. But these are your saturation points. So if I'm looking at this, and I would tell you or ask you a question, I would say, if I have 50 grams of potassium chloride dissolved in 100 grams of water at 70 degrees Celsius, what kind of solution do I have? So if I have 50 grams of KCl in 100 grams of water at 70 degrees Celsius, what kind of solution? So to solve this, we're going to find 50 grams of potassium chloride, which is on this line here. We're going to find 70 grams of, it's on this line, let's draw this all the way across. And I'm going to have 70 degrees Celsius water, which is here, because 50, 55, 60, 65, 70, 75. Where these 2 points meet, that's going to be my mark. So I have 50 grams, so this is going to be right on this dot here, which is going to be pretty darn close to this line. So in the case of that question, that would tell you this solution is saturated. Now what if I had 50 grams of lithium chloride in 100 grams of water at the same temperature? I have all of that the same. So I'm going to stay with my 50 grams all the way across. And I'm going to come up with my 70 grams or 70 degrees Celsius water. Lithium chloride is all the way up here. This is my saturation point. So I can follow this down. And I'm sitting at this location, I'm below that line. So this solution is going to be unsaturated, because I can dissolve up to roughly 110 grams of lithium chloride in 70 degrees Celsius water. So that's those two. If I would have 50 grams of sodium chloride, it would again put me also at 70 degrees Celsius water. Oops. 70 degrees Celsius and 100 grams. I'm still at this location, but this time I'm above the line, so this would be supersaturated. Call it supersat. Supersaturated. So that's how those look differently on a graph for each of them. All right. There are three. Let's go back. As a general rule, like I kind of mentioned earlier, as you increase the temperature of your solution, the amount of solute that can be dissolved goes up. This is true for solids. Solid solids, as temperature goes up, your solubility goes up. If you have a gas dissolved in a liquid, for example, think of pop. What happens to pop when you leave it out of the fridge for a long time? It goes flat. And what's that mean? It means all of the dissolved carbon dioxide inside of it escaped out, because gases are more soluble at lower temperatures than they are at higher temperatures. So that is the solubility of a gas, or gases compared to solids. Now, with solubility, there are three things that affect how fast something will dissolve. Those three things are: one, the temperature of the solvent; two, whether or not the solution is sitting still or if you're stirring it; and three, the size of the solute. So we'll talk about each of these individually really quick, and then we'll be done. So the first one, the temperature. As you increase the temperature of your solution, your molecules move faster, and because temperature measures the average kinetic energy of the particles, so as they increase in kinetic energy, they increase in speed. So the temperature goes up, kinetic energy also goes up, and they move faster. When they do this, they collide with your solute particles faster, or more often. Because they move faster, they pull your solute particles apart. So the more they collide, the faster your solute dissolves, which makes sense. Agitation, your next one. If you stir a mixture or stir a solution, the reason you stir it is to increase the interaction of the molecules. So when you stir it, you are, instead of just increasing the temperature, you are by yourself manually increasing the interaction between solvent molecules and the solute. So it works in the same way that you increase the number of interactions, you increase the solubility, or the rate at which it dissolves. So how fast it dissolves is what we're talking about. And the last one is particle size. Smaller particles have a greater surface area. It's really a surface area to volume ratio. They have greater total surface area of each of the particles than one larger molecule does. Because your solvent molecules attack the outside edges, the more surface area you have, the more surface on the outside that you have, the more opportunities those particles have to be attacked by the solvent and pulled apart. So particle size, the smaller the particle you have, the faster it will dissolve. Because there's more interaction there, the faster it's going to dissolve. And those are the three ways that you can affect the rate of solubility, and that's the difference between a saturated solution, an unsaturated solution, and a supersaturated solution. Thank you for listening, and I will talk to you again next time.